Welcome to 2.3 homework. I've listed all the postulates on the right side here and the answers at the bottom. So do your best not to look at that stuff and try to figure this out on your own. So number one, it says state the postulate is illustrated by the diagram. So as we look at this, it says if AB, if you have 2 points AB, then you have a line that goes through them. Okay, so you have to try to not look at the postulates and try to figure these out. But if you need to look at the postulates, go ahead. But do not look at the answers until you're done. So as we can see, there are two that deal with points. You have a 2-point postulate that says through any 2 points there exists exactly one line. And 2.2 says a line contains at least 2 points. Well, if you have a line, then you know you have at least 2 points. But it starts with just 2 points. So it has to be 2.1, the 2-point postulate. And as we see, the answer to number 1 is 2-point postulate. And you can look at the evens if you want to for extra practice. All right, let's move on. Okay, at number 3, use the diagram to write an example of the postulate. So on number 3, it says a line-point postulate. So what we do is we look at the line-point postulate, which is the second one there. And it says a line contains at least 2 points. That's a postulate. So an example that you could say is, first of all, you got to say that you have a line. So let's say for number 3, we'll say line, or excuse me, let's just go back and do it a different way here. Number 3, we'll say line JH. Line JH contains points J, H, and K. And that would be your line point postulate. You're given a line and you're listing your points. All right, let's look at number 5. 3-point postulate. A 3-point postulate. So let's look and see what we have here. 3-point postulate. Through any 3 non-collinear points, there exists exactly one plane. So we talked about this before. Try not to use 3 collinear points when you're dealing with labeling a plane. So if now it's saying you don't have a plane, it says if you have 3 points, then you have a plane. So we could do something like this. Through, let's do G, K, and L. Through G, K, and L, there exists exactly one plane. And then you can look at the answer here for number 5. And they use 3 different letters. But notice that J, K, and L are not 3 points that are on the same line. Okay, 2 of them could be on the same line, but one of them has to be on a different line. Okay, all right, so let's go on. And again, you have the evens there that can help you. Okay, sketch a diagram. All right, now I know I hate these, but let's give it a shot anyway, and then I'll pop up the answer to each one as we do them. All right, so number 7, plane P. So let's draw a plane and label it plane P, capital P. And line M perpendicular to plane P. See, plane P and line M. Okay, so you want line M perpendicular to plane P. So think of this parallelogram as a flat piece of paper, and you have this line coming down. All you have to do is where it hits, show that you have a 90-degree little symbol on it. Okay, and dotted line on the parts you can't see. All right, so now we label them. We have point P, and then this is line M, lowercase m. All right, so let's take a look at the answer. Presto, and look, it looks just like that. Let's try, let's get rid of that and do number 9. Let's see here. Number 9, let's see. XY, segment XY intersects segment WV at a point A. All right, so you can think of 2 segments like that, but you gotta be careful. How are they intersecting? So it says that XA is equal to VA. All right, so let's just draw real quickly X and Y. and WV, okay, and these are segments, so these are going to be endpoints here, so let's make sure they're endpoints. Okay, and now point A is the intersection. All right, now we're supposed to draw them in a way that XA and VA are equal. So without measuring them, if we just put the hash marks on there, we are to assume, because of the hash marks, and that this is a fact that XA and VA are identical. So because I put those hash marks on there, I have to assume they are identical. Okay? All right, so let's take a look at the answer. And presto, look at that. Almost identical to what I drew. So there you go. Now I'll put the answers for the evens on here real quickly, and then we'll move on. And you can pause it because I'm going to move on. There's 8 and 10 if you want to try those out. All right, so let's go on. Number 11. So 11. Use the diagram to determine whether you can assume the statement. So planes W and X, those are the two planes, okay, intersect at XL. All right, so I'm just going to say there's your KL, just like two walls intersecting. That's where that's at. All right, and can you assume the statement is true? Okay, so planes W and X. So here's X and there's W. Can we assume that they intersect at KL? All right, what do you think? So yes, you can assume that they intersect just by what you see there. Two planes intersect and they form a line. That's the rule. All right, so let's go to number 13. Points Q, J, and M. So let's find Q, J, and M. So point Q and J and M. Let's see here. Now make sure you know which planes they are on. So points Q, J, and M are collinear. Well, Q and J can be in the plane W, and M and J are in plane X. But all three of them are not even close to being on the same line. They actually look like they could be collinear, but no. No is the answer to that one. All right, and then number 15, line JK. So this was the original line we were doing here. Line JK, in red here, lies in plane X. Well, any intersection of all the planes, that line is in all of the planes. So that would be a yes, because that's the intersection of all the planes. And so now we go to 17. Now I'm going to clean up what we have on our screen here. All right, so now we're doing 17. I'll try to tap a little softer. NK says NKL. So NKL, let's do this in blue, NKL. And JKM are vertical angles. Well, that's a yes. Because if you extend the line of one and extend the line of the other one, then the opposite angle would be a vertical angle. Okay, now let's look at the answers, and I'll also put the evens one on here for you as well. And presto, there you go. We're right on. All right, let's keep going. Number 19. All right, number 19. Again, these are very important problems. Make sure you're doing your best on these, okay? Number 19. In exercise 19 and 20, describe and correct the error in the statement made about the diagram. All right, so there's no instructions about what they're doing, so you have to actually read where their mistake is and try to figure it out. So M is the midpoint, so we're looking for midpoint of segment AC. So right off the bat, there's a problem. This has one hash mark and that one has two. If M is the midpoint of AC, then they should have the same hash marks. Okay, and then it says BD as well. So those two should be the same. So here's what it should look like if you have A and C and this is M. I'm just doing it really fast and crudely. So if M is the midpoint, then these two are the same and those two would be the same. That's the correction. You don't know if A to M is the same as D to M. You don't know that. You can't assume that. All right. So let's look at the answer, and I'll also put 20 on there as well. And of course, it says see additional answers. I'm not going to look that up. You can look it up, but what I explained was what it's supposed to be. So you can look up 20 if you want to do it. All right, let's move on. Number 21. Okay, so here's a great example for college prep. Select all the statements about the diagram that you cannot conclude. That you cannot, oops, wrong thing here, cannot conclude. So A, let's see here. A, B, and C are coplanar. So make sure you're trying this before you see how I do it. A, B, and C are coplanar. A is, let me circle them. There's A, there's B, and there's C. And yes, they are, even though B and C are in the intersection of both planes, that means they're in both planes. So A, B, and C are coplanar. All right, so that is, we can, all right? We're looking for things we cannot. All right, let me erase those marks. And part B, plane T intersects plane S. So there's T and there's S. Intersect through BC. All right, that line, and that is true. So we can conclude that. All right, C. Let's go on to that one. All right. AB intersects CD. So let's do AB is right here. And CD, we'll do in blue, is behind it. They do not intersect, so we cannot conclude part C. Great. All right, now D. HC, let's get rid of that. HC, what about HC? Is perpendicular. So we're looking for a perpendicular symbol of some sort. HC, and we'll do that in blue. Here's HC. And it's perpendicular to CD. We'll do it in yellow. Again, CD is behind. I'm sorry, it does intersect at C. But there's no symbol there. The perpendicular symbol is right there, but that's through AB. So that has nothing to do with it. We cannot conclude that. So that's another one. All right. All right. Let's again. And now we're going to do E. It says HC. So HC is this line right there. Is perpendicular to, plane T. E. Plane T is perpendicular to plane S. Well, because you have this line right here, that's perpendicular. AB is perpendicular to that plane, which means they are perpendicular. So yes, we can conclude that. All right. Now F. Point B bisects the segment HC. So there's B and HC. There are no marks saying that they are identical in length, HB or BC. You would have to have a hash mark there and a hash mark there. So you cannot conclude that. And now G. G is ABH, angle ABH. So let's take a look here. Angle ABH is this angle right there. And angle HBF, and that would be going down this way, are a linear pair. And yes, we can conclude that because AB is perpendicular, making T perpendicular to the other plane. So both planes are perpendicular. So we know that that has to be perpendicular and that has to be perpendicular, which makes them supplementary. They equal 180 degrees, which by definition, that's a linear pair. All right, and H. Okay, H. AF is perpendicular. Let's do this right. AF is perpendicular, that perpendicular sign, is perpendicular to CD. Now, CD is not attached to it, but AF is perpendicular because of the two planes being perpendicular to each other. But CD isn't touching AF, so we can't say that they're perpendicular to each other. So this is a cannot. All right, so let's take a look. We have C, we have D, F, and H as our answers. Let's take a look at the answers. And there you go, C, D, F, and H. All right, now let's go do some review problems. Okay, find a counterexample to show that the conjecture is false. If a figure has 4 sides, then it is a rectangle. Well, first of all, a trapezoid has 4 sides. So there's your counterexample. All right, that's false. That's all you had to do is find a counterexample. Trapezoid, you could have said that. All right, moving on. All right, solve the equation, justify each step. So number 33, 3x equals 21 divided by 3, x equals 7. 35, 5 equals x over 7. Well, we've got to remove the 7, so we multiply by 7. So 35 is equal to x. All right, let's go on to 37. 37. All right, 37, a locker in the shape of a rectangular prism. So here, here's your locker, the front of it, and it goes back into the wall. There you go. It's 12 inches wide. We don't know its depth, so we don't understand what that is, so that we give it a variable, d for depth. And it says that the height is 4 times the depth. And it says the volume is 10,800 cubic inches. How many inches made of the shape of a cube, 1 inch on each side of the cube, fits in there? 10,000 cubes fit inside that locker. Okay, so now our volume of a prism is going to be your length times your width times your height. So the volume is 10,800. The length is d, the width is 12, and the height is 4d. All right, so this is going to be 48d squared. That's an 8. So we divide by 48. So take your calculator and take 10,800 divided by 48. And d squared is equal to 225. And you take the square root at that time, and that's 15. So your depth is 15. So find the height and the depth. So the depth is 15, and 4 times that is going to be 60. So it's 12 inches wide, 15 inches deep, and 5 feet high. So pretty close to what ours are. All right, let's go on to number 39. Rewrite the statement as a biconditional statement. So that's your if and only if statement. So go ahead and pause this and write it. And here's what you should write. See, if you can vote, then you're at least 18 years old. So there's your middle, and there's the middle again. If you're 18 years old, then you can vote. Okay, so take out the if. You can vote if and only if you are at least 18 years old. All right, maybe I should try typing instead. It would be quieter. All right, last one, number 41. Okay, I lied. It's 41 and 43. So number 41, all right. Use the diagram to determine whether you can assume the statement. So 41 here, angle DBG. Angle DBG is this angle right here, okay, is 90 degrees. Well, is there anything that says that that's perpendicular, 90 degrees at all? There's no markings on there. Remember, we can't assume. So we can't assume this, so no. All right, so let's look at 43. DC, line DC. All right, so there is a line that exists between the 2 points. That's your 2-point postulate, D through C. All right. Now, the question is, does line DC line the plane DBC? Yeah, of course it does. DC is a line. Those 2 points are in the plane of DBC. So, of course, the line has to be in the plane. All right, there you go.